So first of all, what is this event about? This event is about trying to get you guys, so I can't see most of you, but I'm guessing most of you are sixth formers, and you are interested in studying maths, or maybe you're unsure about whether you should continue to study maths or something else. And also, I'm assuming sort of that you would be interested in studying at the University of Malta, though even though what I'm saying doesn't necessarily apply there. It applies elsewhere, but I can like give particular insight, I suppose, on that experience, because that's where I did my undergraduate. So first of all, who am I? Who are we? What's going on? The Malta Mathematical Society is basically an organization which started, like, I guess, more or less 2 years ago. I guess I'm the de facto in charge guy of it, but helping me out there's Adriana, Georgia, Ethan, Juan, and others, but they couldn't come today. And basically the point of the society is to try and create a bit of a fun math scene in Malta, I guess. I mean, the goal was to do fun stuff like pub events, pub quizzes. I always mention that one because it's what I wanted to do, but I still haven't done that yet. But yeah, that was the goal of it, to do these fun events, also talks and educational things around maths in a sort of extracurricular way, to create a bit of a community around maths in Malta. And I guess we thought that we are particularly well suited as sort of math students who've gone through the system recently to give you guys some advice as to what it's like to study maths versus not studying maths. So first of all, I have some notes. Okay, so I guess I should start with the obvious, the main thing which people care about when they study, I guess, well, most people, is the career opportunities angle. Okay, so the career opportunities with maths there's loads of stuff you can do. Okay, so because mathematics there's loads of reasons why there's lots of stuff you can do. So let me start with perhaps the most superficial one. Math somehow has a reputation of being difficult. Okay, so even simply by choosing to study mathematics at university, it's a testament to your ability to be a generally good problem solver, thinking about hard things and not minding thinking about hard things. Okay, so basically, even if you end up pursuing a career which does not necessarily have mathematics at the forefront somehow, the fact that you study mathematics will definitely be advantageous. Having said that, mathematics is very directly applied in anything to do with computing, right? If you want to do software or anything like that, going with a maths degree is definitely an asset to applying to or considering a career like that. Also, anything to do with finance, anything to do with science or engineering, right? Now, obviously, there are more targeted courses towards these things, but also mathematics. So at least again, I'm speaking about the University of Malta here. The way courses are offered here is mathematics tends to be paired with another subject. Okay, so perhaps those, especially of you who might be confused about what course to pick. For instance, there's a course like computer science and a course like mathematics and computer science. Not like, I'm using the word like, there are those two courses. And you might be confused which one to pick. Okay, so should I go just for the CS one or the maths and CS? Now, my experience, I did maths and CS, and the skill set which I was endowed with as a consequence of these courses, of this one course, which was made up of 2 parts. I definitely do not regret it, of course. I think it was one of the best choices I made to choose maths and computer science. The reason is, well, they help each other a lot. They tend to, how can I say? So the reason, the philosophy behind the courses is very different. Let's say this. Okay, so mathematics, even though I've just said there are loads of career opportunities and applications for it, the mathematics course itself, and this is true, like I said, not necessarily at the University of Malta, but in general, when you study a mathematics course, the philosophy is to be very explorative, right? In the sense that you learn about something mathematical and just explore what you can about it, okay? You make up a concept like a prime number, okay? And then you say, what can we say about prime numbers? And you elaborate, sort of squeeze the definitions to death and see what they can give you, right? With something like computer science or these more specific career-oriented courses, mathematics tends to play a sort of secondary role, not necessarily secondary, but you only ever tend to learn the mathematics which is necessary to do the stuff that you need to do at the end of the day. Okay, so if you're doing computer science, even though computer science, when it comes to the spectrum of courses available in IT, it tends to be the more theoretical one, but still it's concerned mainly with programming and doing stuff on a computer, basically, even though it's on the more theoretical side. So the nice part, so there's also an advantage to this, of course, this whole having maths with something else, because maths is at the end of the day a bit abstract, and some people might feel like there is a lack of motivation sometimes, even though that's not the case. But a lot of courses, some courses are purely theoretical that you will do throughout the course. I'm using the word courses. I guess the terminology I should use is study units, okay? Because the course is made up of many things. And that's what I meant by course. Like some study units are very theoretical, and they don't have many applications. So you might just, like, it's just maths. There's no like, we're going to do something with it. It's just the maths for its own sake. Although there are, of course, other things in the maths bit still, which talk about applications. But I guess there isn't really something like that with the CS part. And I'm guessing, I can talk mainly about CS, but if there's someone here who could comment on like physics or anything, there isn't a course in the CS part which is 100% focused on the theory aspect. There's always a goal somehow. Not that the maths, it's difficult to distinguish this without being concrete, because it's a bit of a fuzzy line, I suppose. But the maths, certain courses tend to be concerned mainly with the maths. Now, this duality is very nice, because sometimes, like I said, what I was initially going to say was the CS part, you start the lecture with like something theoretical or just a concept, a goal, and by the end of the lecture, the same lecture, you're like programming, you're doing something, and you're seeing an end result. So you don't necessarily always see that in the maths, and in fact, you rarely do, even though you do solve concrete problems at the end of the day. But they tend to be of a more mathematical nature. In the CS, it's much more sort of a radical change. Again, does anyone have like a physics analogy maybe wants to interrupt me?
Maybe physics, we could say, we kind of study all the maths that we would use. We mention parts of it, but we never really go into the detail of why things are mathematically. We will obviously make some deductions and show some certain things. For example, if we're studying quantum mechanics, we will need the ideas of linear algebra. So we'll need the ideas of vectors and matrices and how they interact with each other, which we do go into, but it's when you study it in maths, it really gives you a deeper understanding of what's happening within the equations.
Yes. In fact, a big motivator for me, thanks Ethan for that, a big motivator for me is, let me just make up a term, I don't know if it exists, like mathematical discomfort, okay? So I remember when I did my A-level, something which really annoyed me, or yeah, I guess it made me uncomfortable, was the fact that we would say that something like, dy by dx or something, dy by dx, that's just a symbol, right? It's just a notation, it's not a fraction, it looks like a fraction, okay, but it's not a fraction. Why do we use it then if it looks like a fraction, it's a fraction? Because then later on when you do integration, you do something cheeky. You sort of, if it's equal to like cos x or something, you move this to the other side, right? And no one bats an eye about that, even though a few chapters ago you said it's not a fraction. So there's all this stuff, which is a bit not done well. And to be fair, it's not like the issue is, yes, so let me refer to my, okay, yes, so, because there's a lot of stuff I want to say, I want to make sure I don't mix up the order or stuff. So the issue with this thing is that Maths A level, right, I'm guessing most of you are coming from Maths A level, but even a similar course, right, if you're still at this point in your educational journey, pre-university level maths, basically, usually the goal of it is not to do maths, in the sense that Maths A level, for instance, it's a prerequisite for many courses like engineering, architecture, computer science, all these courses. And these people might not necessarily go on to do maths, they might do just this stuff. So they would retain this sort of philosophy. So the point is, it's a course made up of stuff which architects, engineers all met in a room together and said, I think students should know this stuff for our course, and so on. So it's this weird mishmash of stuff, which is just like skills you should be able to do, okay? So mathematical skills, like being able to do a maths thing, is very different from understanding it and really getting the picture, right? Now I like to, I always like to demonstrate with calculus in particular. I don't know if this is a very famous book on calculus, Spivak's calculus. Okay, so look at how thick this chap is. Okay, so if you were to do all this stuff properly, the reason you don't do all this stuff properly is because you'd have to do all this basically, and you don't have time for that in 2 years. Okay, so there's a reason for it. But yes, what I was saying is that the goal of the mathematics that you would do in these other courses like CS, etc. I guess, okay, I don't want to be too unfair. I don't want to like make it sound, it depends on the course at the end of the day, in the mini course, on the study units. There might be ones which are purely theoretical. But even, for instance, if I recall correctly, physics people, they do maths for physicists, right? And even, for instance, computer scientists, people who take computer science but don't have the maths option, they do something called maths for engineers. And it's not maths in the sense, as in it is maths obviously, but it's not maths in the sense of we're trying to discover and understand things from the bottom up, and that's all we care about. Because if you take that philosophy to it, there's no rush, or there's no like, maths is the central protagonist of what you're doing, so yes, let me see what else I wanted to say. Okay, so what is maths actually like at university? It's another obvious question. So the nature of maths, because of what I just said, that you're not working out sums or whatever, you're not like doing integrals, like that's not what it's like. You're mainly concerned with proving things, whether things are true or not. So for instance, I don't know, every differentiable function is continuous, right? So this is a mathematical fact. What does it even mean? I mean, the thing is, this is the stuff you'll be thinking about. What is that? You would be proving things like this. Okay, you'll be proving, what's a proof even? Like, so in A level or whatever similar courses, you do proofs. They are proofs. I don't want to do the air quotes. They are proofs, but like of trigonometric identities or something like that. But that again also somehow feels mechanical. And basically, you can sum it up. It's like you can really. It's very algorithmic. Change anything which isn't sine and cosine into sine and cosine. Remember that sine squared plus cos squared is 1, and basically just mix those together, throw it at your problem, and we'll solve it, right? So that's basically what that is. So it's not difficult proofs that you do at A level. You might do some fancier proofs, I guess. It depends on your teacher and how rigorous they want to be about what they're doing. But fundamentally, the goal of A level mathematics, and the mathematics presumably you have been exposed to so far, is not to prove things or to see what is true about certain mathematical objects, but to use them and apply them to other things. And A level is just learning the stuff. They're just waiting to be applied. Just like you've done integration, you've done all the stuff, but you've just done them, you've learned them, you've gotten reasonably good at them, and then once you jump into your course of choice, you will apply them. But you will not, especially if it's on the more applied end of the spectrum, you'll not really understand them. Okay, so if you go for engineering or something like that, okay, you'll mainly be applying more of them. And you will be, even fancier techniques, I suppose. But then again, you will never really reflect on the stuff you did before and truly get into the meat of it, which is deep at the end of the day to really understand it. So yes, this is what mathematics is like at university level. You'll be doing mainly proofs. This also changes what it's like to study maths. So sometimes it's weird. So I teach mathematics. I give like private tuition and so on. And sometimes I get students who don't get how they should sort of study. They just read the notes over and over again, which is not sort of, I don't know, if you're doing literature or something, I guess that's fine, even though you should write stuff down yourself. But students who do that and do not do practice problems will not get good at the A-level type of maths. In contrast, though, it tends to become even more like these sort of more memorization subjects as you go further on, in the sense that at the end of the day, certain advanced proofs, you will be asked for them in an exam. Okay, so I'm trying to give you a picture of like what the logistics of the course is like. So like day to day, you have an exam. What's the exam going to be like? What is a typical maths exam? This is what I'm trying to do here.
They examine concepts, the understanding of a concept, rather than trying to see whether you can make a calculation and get the correct answer.
Exactly. So there's no correct answer. It's almost like you write paragraphs. It's weird to even describe to people who
paragraphs and equations and
exactly like paragraphs and equations. It's like a weird mix of the two. But yes, it's much more like you're explaining and reasoning. Yes, this is another point I haven't touched upon yet. What even is maths as well, right? Because I described the A-level point of view, and I said it's not like that, but what is it like? Mathematics, and this ties into what I was just saying now with the proofs and so on. Mathematics, in a sense, it's much more abstract than the way the A-level or any other sort of pre-uni course depicts it, in the sense that it's mainly about just reasoning abstractly, like reasoning about abstract stuff, making something up and just squeezing, juicing, out all the logical consequences you can of that thing. I gave the example of prime numbers, but anything, you could make up a thing, so something that's coming to mind is, like a metric space, okay? So a metric space is something where you have objects, you never say what they are, but you say that you can somehow measure them, okay? You have a way to measure distance between them. So these can be the most obvious examples, like points in space, you have the usual square root thingy, distance between 2 points, but there can also be other weird things like words, the distance between 2 words, okay? Like, I don't know, you can like see how far away the letters are, the distance between 2 functions, okay? Another weird thing, like how far is sine x from cos x, but you can create this abstract idea of a metric space, and you study metric spaces generally. So you never say what you're studying. You never say we're looking at functions or we're looking at words or points in space. You say we have a set of stuff and we can measure the distances between them.
Another example that's probably slightly more familiar is vectors.
Mm-hmm. Yes,
vectors.
Big brain comment. Yes, very good. I should have gone with that one. Yes. Carry on.
Vectors, you probably know them using Cartesian coordinates or maybe even polar coordinates. They're just a list of numbers. But in reality, the way we describe them is algebraically. Like we say that they're a set that combine in a very specific way. Like you can add them or multiply them by a constant or something like
that. So what Ethan is saying, in
that sense, are vectors.
It's similar to what I was saying in that we have, I said a metric space. Another thing is a vector space, which is what Ethan is saying. A vector space is probably an easier example. Basically, so let me just give you an example, which should make you, if you find this thing nice that I'm about to say, you should pick maths, okay? So look at this. So if you have like let me do the whole like underlining vectors thing, right? So you have x, that's a vector, and y, and like I guess a constant, let's say like alpha and beta, those are constants. Okay, this is like a typical vector thing. And that transformation is like a thing you do like this, okay? So let me just write this down and I'll explain what I'm trying to say. So this is what's called a linear transformation, okay? So if you imagine that they are literally A-level type vector thingies and that T is a matrix, then the thing I wrote down here is obviously true. Can you see it, by the way? Is it clear? Like, I don't know. Because I'm seeing myself all the time.
It's clear. Yes, it is.
Right, thank you. So this is something which is obviously true for matrices, right? Like the matrix times a vector sum is like you can split it over the plus. And the constants can go outside, sort of. So this is how it worked out, like M, U, and V instead of X and Y. That's how, But there's other stuff which behaves this way, right? So a nice example, if you imagine the X and the Y are functions, and these are constants, and T is differentiation, for instance, okay? While they're different contexts, but they are the same thing, okay? Now, if you like take the big-brained maths approach, okay, you'll actually realize that this is the fundamental thing for vectors, okay? And a lot of stuff which vectors and linear algebra and the matrix, like matrices and vector stuff and functions exhibit, are very similar, okay? So if you study stuff, things, we call them vectors, but when Ethan said vectors, they could be functions, they could be anything, okay? Like we just things, but they behave this way, they have this behavior. If you have things which do this, and we never say what they are, we just study these things which do this abstractly, you can say a lot of neat stuff, okay? Such as if a transformation does this, then if you do it to 0, it will always be 0, okay? So like matrix times the 0 vector is 0, but also the 0 function, which I guess is 0, f of x is 0, its differentiation is 0, okay? But this is just a very easy one. You can do more fancy things, obviously. And they're all continuous as well. You can say a lot of fancy stuff about them. But yeah, so this whole thing that I just did now, I connected matrices and the way they work with functions and the differentiation process. if you thought that if you think that is cool, the fact that they are connected, the fact that you can sort of take this global view at the two separate things and connect them, that's very much what maths is all about. Okay, so you just look at things more and more abstractly, and that's what you will be doing, right, for 4 years if you pick this course in the maths component. Yes, so this idea of looking at things and trying to draw connections between them and define a more abstract, in a sense, fundamental thing. So somehow, this thing here, since this applies to vectors in the A-level sort of way, and it applies to functions, but if it's more productive to study this, because if you study this, it applies to both automatically. Somehow this is truer, okay? It's a bit more abstract and complicated to explain to a student who's never come across these things, so you have to do the A-level stuff. But this is nice, really, and it's very nice, basically, something. But if you found this interesting, then you should definitely go for the maths option. Now, also, because I haven't, I sort of started talking about this, but I sort of stopped. This sort of reasoning is present in the other subjects, okay? But since it's sort of scarce, in my experience, because I'm not one of these people that didn't choose maths, I see like my classmates struggling with this sort of stuff. So, for instance, when I was doing my computer science degree, we'd have something like there was a module called formal languages, okay, which is like basically studying programming languages and how they work and so on. To me, it was quite an easy unit because I was quite used to thinking abstractly about things, okay, about doing this whole global bird's eye view of stuff. Whereas my classmates who were more used to the CS only mentality they found this quite a challenging study unit. I didn't get that, but mainly because doing maths sort of desensitizes you. What's the best word? It basically prepares you. It makes you good at thinking abstractly, okay, about seeing the bigger picture, you know.
I mean, it's not even because they're not like smart enough people. It's not because you get. I'm not saying you're saying that. It's not because you get smarter in a way doing math. You do, like the. It's in CS on its own. You have these concepts, and they're looking you right in the eye. But you don't ever explain them. You just use them, and if you see the connection, that's nice, and you'll do much better. And if you don't see the connection, it's never told to you or explained to you. So when you start building on it, you get lost because you don't have the foundations, and that's what maths is. It's the foundations for logic, basically. That's why it's so good.
That's a very good comment, Adriana. I mean, the idea of logic as well, like I said, like reasoning abstractly, that's basically, the mathematics is the art of reasoning abstractly. That's the best way, that's the best description I could give of it. Because it's difficult to, I mean, even you guys who've done A-level, right? If you try to explain to people who did O-level maths and then didn't continue it, it's probably hard to describe to them what it's like. But believe me, it's much harder for me to describe what this stuff is like right now, because it's very nice, it's very abstract, but it's very different. Fundamentally, it's very different from A-level. Like the computation aspect completely goes away. I don't even think about maths in terms of computations, in the sense that you're working something out and getting an answer. Obviously, there is that aspect to it as well, but it's really not what it's about. You know, it's not what it's about at all. It's about just reasoning, just starting from a thing and seeing what its consequences are. Okay, and this applies. You know, I mean, philosophy and mathematics go hand in hand. I mean, you know, logic, I guess it's philosophers and mathematicians like fight over who it belongs to, I guess, but it's really maths is sort of logic. I mean, it's the natural consequence of logic, and all you do as a mathematician or as a math student, I guess, is apply logical ideas just to different objects. Okay, I mean, this formal language thing that I was explaining, which was a CS computer science thingy, that might as well have been a maths course, in that we describe this thing, a formal language, and the idea of a formal language is to describe any programming language without being too specific about the syntax. And we sort of explore the consequences of what a formal language must have, what all languages must have. You know, if you have a language, what properties must they have? What are the cool things? Certain languages have this, certain other languages have this. Some are, you know, eager, some are, what's the other word? Lazy. Yeah. So there's all these different properties of languages. But this is just a thing which the computer science people find interesting. In maths, we study vector spaces and metric spaces and so on. I mean, the flavor that the subject takes on depends sort of, it just depends on like the stuff you chose to study in the beginning. Okay, so there's this big split that you will feel like probably in your second year of the course if you decide to study between like algebra sort of stuff. When I say algebra, I don't mean the high school or A-level algebra stuff. I mean like the area called abstract algebra, which is more to do with these linear transformations, other things called groups and so on, as opposed to like analysis, which is more metric spacey, like stuff I just mentioned now. And they have a different vibe, a different feel to them. But it's all maths somehow, right? It's all just starting from something and seeing the consequences. But yes, maths will be the ultimate course to really get good at the skill. Okay, it's also something which I feel personally has made it easy for me, or easier, I guess, to really get to the point of what I want to say. Even though this is probably the worst thing I should have said, like after I've been rambling. But what I mean is to really be careful how I articulate things and so on. I'm not saying like, okay, so I'm not saying like maths is a course about public speaking or anything like that. What I'm saying is it helps you think, helps you reason. And if you want to say something or communicate something even, it helps you see what the point is, like sometimes when you see something, when you get a eureka moment, when you understand something, you really get to it through a weird way. Like people think differently is what I'm trying to say.
It helps you think logically.
Yes. It helps you like get rid of the fluff, trim the sides or whatever. Right?
Even from in societal like situations, like for an example, if you're reading through a document and you see logical inconsistency somewhere, you'll realize something.
Yes, very good.
A good example in history. I don't know if you've heard of Gödel. He had when he was applying for American citizenship, he was reading through the Constitution and found inconsistencies in the American Constitution, and ended up, pointing it out to.
Because I mean, in a sense, also, and this is getting like a bit deep now, but maths is somehow a language, right? Maths is a language which used to communicate with. We try to communicate ideas precisely. It's like the most precise language you can come up with to describe things precisely, better than English or whatever. But then also, if you think very mathematically, you start to spot these things like Ethan mentioned. So for instance, something which is coming to mind, I saw this in the beginning of like, I forgot what textbook it was, but if you say something like, for every man, there is a woman, so hypothetically, or like, for every person, there is a partner, or there is a partner for every person. I just switched the clauses around there. They actually mean something different if you take it logically, right? But people don't sort of realize that immediately. It makes a difference, like the order within which you say these things. Obviously, context helps. If you're reading a book, I guess you won't really think twice what I'm saying, if it's like in a story or something. But yes, like to really be careful with words. Like mathematics also contributes to this mindset. Okay, just being very careful and logical about things generally, no matter what they are. I mean, in mathematics, the objects which came to be of interest are those which they are, like metric spaces and so on. They're very natural, basic things which you would want to understand, like sort of fundamental in a sense, like something which distance, a metric space. Obviously, distance is quite a basic idea, so it's a useful thing to study. But like I said, in the CS side, they study the language stuff. They also study the very same stuff in linguistics as well. So maths pops up in unexpected situations there as well. Okay, so I was meant to be following a document I had. Okay, so did I mention everything? Yes, so mathematics, obviously, it is a bit. So if you're like uncertain about whether to choose maths or not because it's difficult or something like that, this is a bit of a, I don't know, it's difficulty is the wrong word to use, because I always say like the hardest thing to do is the thing that you don't enjoy. Okay, so it's not true that, so let me preface this. math isn't for everyone in the sense that, yes, it is hard somehow. But given that you've gotten to this stage where you've done your A levels, you've probably done well, you're thinking of, if you're even thinking about continuing to do maths, I assure you that you're good enough to do it. So you shouldn't be afraid of that aspect of it. But whether you enjoy it or not is sort of what you really need to understand, because if you enjoy it, then you won't find it hard. I mean, I remember, I always bring this example that, not to this people who are into like teaching the languages or anything, but I worked as a summer job. I did like teaching TEFL, teaching English to foreigners, like basic English. And to do that, you need to do this course called the TEFL course, and it was the most boring thing. It's just boring, I don't like it. It's boring. That was the hardest thing I've ever done in my life, I'm sure. Like educationally speaking, all these courses on topology and so on, they're nothing compared to the difficulty of TEFL courses, like a 2-week TEFL course. But yeah, no, I'm serious about this though, genuinely. If you hate something, it's impossible to just sit down and do it. I mean, you just need to be motivated to do whatever you need to do. And if you find something interesting and you think it's cool, you will do well at it, I'm sure. Like I said, you shouldn't be put off by people for whom maths is not a thing, not a viable option, would not be in this call right now.
Can I say something a bit?
Yes, of course.
In the start, I have to say, like, I love maths, and when the start it was, it's very different. It's a complete, because in A level they give you methods, you follow them. When you see a question, you know the answer to the question. It's never like this at university, but in that sense, there's resistance personally for me. Like I see a question I don't know the answer to, I immediately panic because that's what I'm used to. Doing this more and more, you get used to it, and you realize it's not as hard as you think it is. So I think the people who find maths really difficult find it difficult because they haven't gotten used to that initial, oh no, what do I do? So after you do that, then it's much easier and it's a lot more enjoyable to me than memorizing things,
Exactly. I mean, especially like if you have, I don't know, this is like a comment on the education system as well. I mean, so not necessarily on the education system as it stands, in the sense that obviously for A level, you're going to be given problems which are sort of standard somehow, they're going to have an easy solution. You'll have seen them before, basically. If you haven't seen something, it's very rare for you to come across a question in an A-level paper which you haven't done exactly the same thing, unless you just haven't studied, because if you haven't studied, then obviously. But if you've studied and done enough stuff, the questions which come out in the A-level exam are basically the same as something you've done at some point in the past in your homework, just with numbers changed. Right? Most of the questions, there might be like part E to a question might require a bit of thinking, but like A, B, C, D, which have the most marks, you'll have done all of that stuff. This is also true to a lesser extent at uni as well, in the sense that, as I mentioned earlier, like you mainly be learning proofs, and some of the proofs, well, the majority of the proofs, you probably, they're just from the notes, okay? So you'll be learning those. But, so I was going to, hang on, because Adriana, you said, what do you say? You said that it's difficult. Oh yes, the transition. Okay, yes. So also the transition from uni, from A level to uni, it might not feel. They try to make it as painless as possible somehow, in the sense that it might not feel radically different at first. Okay, it might feel a bit like similar to A level and the stuff that you do, but that's just so it's not too shocking, But yes, the fact that the true picture of maths at the end of the day is you're not given problems you can solve. Yes, this is what I'm saying. You're not given problems that you can solve, right? As in as what I say this in real world mathematical research contexts, right? Real mathematicians do not think about problems which they can solve, otherwise they wouldn't, there's no point. So maths A level is very much problems which you can solve easily because you've seen them before. In university level maths, you might be given problems, especially maybe not necessarily in an exam, okay? But in an exam to a bit more than the A level, okay? So in the A level, I gave the analogy now, like the part E of a question would be like unseen. Maybe in the university system, like, I don't know, 20%, okay, of the whole exam might be something which you need to really apply the ideas that you learned. But really apply in the sense that it's an unseen problem. But yeah, like real maths, doing real maths at the end of the day is solving problems which have no solution as of yet. So that's what research is all about. And the maths course is preparing you to do that. Now, that does not necessarily mean that that's the only reason you should choose to study maths, because like I said, and there are loads of careers which, having studied maths, it would put you at a great advantage for. Okay, so even though you have those skills which are meant to prepare you for a research career, hypothetically, they obviously prepare you for other stuff as well. I mean, I say this just from personal experience. Just because I had maths and computer science, as opposed to computer science alone, if I were like applied for a job which had to do with the tech industry, I was automatically somehow this more impressive guy. Okay, just because I studied maths, because a lot of people find maths scary for whatever reason. But that's just probably like a failure of market. Well, not a failure in a sense, if you've studied maths, you're like somehow more elite, but it's not really that hard, like I've been saying. If you enjoy it, if you find it's fun, this thing that I just said now, like making these connections between two disparate areas that like at first glance have nothing to do with each other, it's a very beautiful thing at the end of the day. I mean, that's another comment which I haven't really expanded on, but math is beautiful, obviously. But I mean, the people you're talking to are quite biased in the sense that we're obviously going to find it beautiful in the Malta Mathematical Society. But it is truly, it's somehow, in my experience, it's the most like deep thing I can think of. I enjoy. I like. Okay, this is gonna sound, I don't know. Like I like reading about philosophy and so on and history. Philosophy is particularly deep, I suppose, especially. But somehow it's not as satisfying as mathematics, purely because mathematics is so. I can't think of something like maths in that it really builds on itself. Like to understand this, you need to understand this very well, this very well, this very well, and so on. I tell this to my students all the time, like my A-level students even. If you still think about partial fractions, in that if you still like don't do them automatically, like when you integrate with partial fractions, like you'll be thinking about the partial fractions, like, hang on, how do I do these again? Like you shouldn't think about that stuff. If you're trying to work here, you can't afford to be thinking, you can't afford to use like memory, like processing power in your brain to do this stuff. Like this should be really easy. And similarly, at university, all the A-level stuff, it's like Tower of Babel type thing. Like you should be operating up here, so I can't think of anything which is, I mean, obviously other subjects build on each other as well, but mathematics literally, like if one sort of thing is weak in that structure, it will crumble down. But yeah, because of that, it's just really satisfying because like everything comes into play. It's very mentally satisfying. Like it feels rewarding. It's fun to do. Okay, so I think, to make sure I mentioned everything. Math is challenging. I said that, but always leaves you wanting more. Yes, I said. Okay, so yeah, I think I said everything that I think I need to say. So I think this is a good point to sort of open the floor. So like questions, if you guys have any questions which I haven't answered within my rant. You can also type in the chat, by the way, if you like. And also, if like any of you guys would be MMS chaps want to add anything.
I think you've kind of said it all, and
thank you.
The one thing I wanted to kind of interject about, it's difficult to interject you.
Okay.
Is that the whole maths being able to solve new problems that you have never seen before? It's not just an academic thing. Like in real life, if you're programming, if you're a scientist, if you're working with a company, you're going to face problems which no one knows the answer to, which is why they're problems. So you have to be comfortable with that. And I think maths is, at least I do maths and CS too. I'm more challenged on that, on the math side than the CS side.
Maths is more for understanding the fear of the unknown, and dealing with that in some sense.
Yes, thank you. I mean, I think I'm just so, I'm so, personally, I mean, I'm into academia and so on. So maybe I was like, it's good for research and so on because that's my thing. But yes, Adriana brought up a very good point. Obviously, anything real world involves, it's not going to be like handed to you on a plate, like this is one of those, you're not gonna have that A-level feeling like, yes, I've seen this. This is like, it's like example 3 from the notes or something like that. You're not going to have that. Well, actually, you actually do have that, more surprisingly than you think, in the sense that the tools you learn from A level are surprisingly versatile as well. So it's sometimes weird how sometimes things feel weirdly specific, but they're not. They apply more generally. But yes, in the real world, most problems that you face don't have just like easy out of the box solutions. And maths, as Ethan so eloquently put it, is about overcoming the fear of the unknown when it comes to trying to come up with big brain solutions to problems.
Another thing to say is like if you're not too into the pure stuff, there is more applied parts in the course as well. So you can go into learning about how maths applies in the real world as well. It's not just all about algebra and analysis as Luke.
Yes, yes.
There are. In fact, in your third year, you end up choosing a stream. You get to choose like between basically applied maths. I think you can do biomathematics as well, theory and combinatorics.
Yes, I wish we had like people who sort of you took applied, لا Ethan.
Ian applied that.
Exactly. Thanks because obviously, like I don't even notice my own biases sometimes. Obviously, so I please interject me and so on when I if I give the false picture. But yes, inevitably, obviously, to the people listening to me, the stuff I said is because of the sort of experience I've had with the course, and sometimes I leave things out. So it's like Ethan brought up the applied thing. So if anything, what I've given you, if I gave you an impression of the course, it's sort of a subset of the true possible picture that you might have of the course. But it's all good stuff in the sense that if what I said piqued like 80% of your interest, and like 20% of what I said was like, I'm not really into that. Most likely there's a path throughout the course which you can take, which will make it different to what I said, and that, maybe you're not particularly very into this thing that I mentioned, but maybe the other stuff in maths that you feel is somehow purely mathematical. Yeah, if you like the maths for its own sake, basically choosing maths is definitely a good idea, and I'm sure you'll enjoy it, because the only reason you would pick it but won't enjoy it is if you just don't care about the maths. I mean, that's fundamentally it. Because if you took like maths and something and you want to continue on that something, but you like the maths, and there exists a maths like maths and chemistry, say, like Carl here in the audience, he took maths and chemistry, maths and chemistry.
Yep.
I mean, I'm sure, like, would you agree to like maths and X definitely sheds light on and improves your understanding of X
Definitely. Honestly, like the intersection between maths and chemistry isn't a whole lot, pero I found that sort of doing study units in maths alongside some of the stuff that I did in chemistry sort of like not shed light, but sort of helped me understand certain things in chemistry. Example, stuff in thermodynamics, molecular modeling, affarijiet in a more fundamental light. So
I guess even electron structure or something like that.
Sorry?
Spaces comes into all of that.
And so I mean, yeah, if you want to go into that sort of detail, yes. I
guess that's more of the realm of physics then.
Exactly, because like in chemistry, really and truly,
like
the maths that is needed is just A-level maths. There's an entire unit dedicated to that, which I had to take because I don't know.
So, is it like maths for chemists?
It's basically maths for chemists, which is a 6-credit unit that is basically A-level maths. So 3 credits, I guess. You're welcome.
With a maths.
No, I mean, I know it's also like a meme, but it's like it's all connected, man. Like it is a meme, but it is true. I mean, I tell you, the more stuff. That's why, I mean, in a sense, it's like a life philosophy. Like the more you learn about stuff, and the more it's like everywhere. You can never learn something useless. But with maths, especially, I mean, maths is really, it's everywhere. Like once you learn it, you'll spot it everywhere. So yeah, I think we've said everything. So like, please, if anyone in the, the sort of camera off mic muted section of the audience has anything any questions or and if you want to post in the chat.
I think what we forgot to, like, obviously send questions, like interrupt me, I don't care. Even if you don't like, if you're not going into maths itself, but you like maths, the MMS is for you, you know, it's for all of us.
Yes, that's definitely something I want to mention. Very good, Daniel. Thanks for reminding me. Like so the dream of the MMS, right? So this is like outside the course. So one, I think, I can't think of a reason why you shouldn't pick maths. So it's like, again, this is like me biased in the sense that, yeah, I mean, I'm sure whatever you want to study, if you're between like X or maths and X, I'm sure picking maths and X as a course would definitely help with your any goal you have, I'm sure. The only thing, I mean, okay, if you like really want to get your degree done in 3 years instead of 4, there's that to consider, but that extra year is definitely worth it in my view. It feels like, to me, it feels like I have 2 degrees. That's what I feel like. I mean, because the CS, don't think like maths and CS. The people who do CS alone don't do more CS than you do. Like, you still do as much CS as they do. And oh, thanks, Ethan. So you do as much CS as they do, plus an extra maths bit, okay? So yes, so you will definitely, there's no advantage doing CS alone, sort of. It's not like half and half. It's like 1 and 1, okay? So it's like 2 courses. And also, yes, the MMS. So the dream of the MMS is to be very, what's the word? Interdisciplinary, sort of, you know? So obviously, if you do decide to pursue maths, which I encourage you to do, we would like you to be a member of the MMS and like come to our events and stuff, please, you know. But even if you don't choose to continue to study maths, it would be even cooler if we have like non-maths people being interested casually in maths, you know. I mean, it's very, we don't do like fancy maths, you know, in the sense we do a bit, but it's you know, it's all good in the sense that it's like a number file type of vibe, you know, like we try to be as open to the public and so on, you know. So these events are technically open to anyone who's interested in maths even a bit, you know, so it doesn't have to there's nothing fancy. I mean, if you have most people assume, and most of our events have in mind the fact that we will have attendees who are basically not more than an A-level understanding of mathematics. So yes, we would really enjoy it if you take part in the MMS on, you know, if you don't pursue mathematics. If you don't care for either option, at least please like us on Instagram, or what's the word? Follow Instagram, like us on Facebook, yes. Okay, so yes, and Juan just posted a debate that we did recently, which is whether mathematics is invented or discovered. That's a good to give you a vibe of like the sort of events we do. They're quite informal, fun, like sometimes competitive even events like that one. Not always.
And if you're interested, we've got a couple of events coming up. So
yes, as well. So you know, what's the word people use? Like watch this space. What's the social media trendy? As that like our stuff and so on. So does anyone have anything to add or any questions?
Most of the things were said. I was going to add something upon like maths being a fear of the unknown, and that is the main thing which actually like it becomes a drive. It becomes a drive for solving these hard problems which nobody can solve. And if you're not into that thing and you still want to do, and a reason why you should do maths, and if you like doing hard things, you can at least try to solve one of the millennial problems as well.
Of course,
what Juan just mentioned is there's this famous there's 7 unsolved problems in maths, and like if you solve them, you'll win $1 million. But yes, I think you know a university level course is at least like a prerequisite if you want to pursue something like that. Okay, so I think you know, no one seems to be posting questions in the chat or anything, so I think we said we brought up all the relevant points, I hope. Yeah, I think so. But yes, definitely, I mean, this thing I mentioned is worth keeping in mind, especially so because I'm so academically oriented, I don't think of the careers aspect, but me having chosen maths and computing as opposed to just computing definitely helped my computing job prospects, because I received also oh yeah, but just because I chose maths, I it's very easy to, it feels, at least, maybe this is me being a bit cocky, I don't know, but it feels like it feels a lot easier than, to get like an interview or something, to get to the interview stage of a job application or something, just because I studied maths and computer science as opposed to computer science alone. That's the vibe I get of talking to my friends who did computer science alone, sort of. But yes, okay. So I think, shall we? Does anyone else have anything to add? I think we can basically conclude there because no one seems to be posting any questions.
See you all next year. Oh.
Exactly. So I'm guessing this means I've convinced everyone. There's no questions. We've convinced everyone. Sorry.
See you all in the course in a few years' time.
Exactly. Looking forward to seeing you all there.
And at our next talk, of course.
Exactly. Our next events, especially. We have an event coming up. When's the next event? I think we said, is it going to be next Wednesday? Exactly. Like an informal. I don't think we've settled on the theme yet. Anyway, there's going to be a Facebook event up very soon. So yeah, watch out for that. So yeah, basically, thanks for everyone who attended. I hope that our